Hello, students. You're welcome to the final session of Unit 6 and the final session of the module on pedagogical content knowledge in physics. And in this session, we'll be looking at assessment strategies. My name is Patrick AJ. Now, at the end of this session, you should be able to understand and adopt good strategies when doing classroom assessment. So let's look at the various assessment strategies that you can use as a teacher in the classroom. And so as teachers, we are encouraged to develop our own assessment for physics based on student learning requirements and the prescribed student learning outcomes. So the various assessment tasks should be based on the objectives that are being set for the set of instructions, so that if our set of instructions are such that students should be able to explain, they should be able to demonstrate, illustrate, then our assessment task should help us assess these features or these competencies from our learners. And so some assessment strategies that you as a teacher you can use in the science classroom include: we can use observations, we can use interviews, we have group or peer assessment, we have self-assessment, performance assessment or student demonstration, we have science journal entries, we have rubrics or checklists, visual displays, laboratory reports, pencil and paper tasks, research report or presentation, interpretation of media reports of science, demonstration of an understanding of the major explanatory stories of science, asking and answering questions based on data, and recognizing the role of evidence. All these are strategies that the teacher can use in assessing students' learning outcomes. And so in the subsequent session, we will be looking at some of these strategies and how the teacher can use such strategies to assess students' learning outcomes. So let's look at observation. And in observation, we must understand that it is an integral part of the assessment process. And this integral part of assessment process is very effective when it is focused on the skills, the concepts, as well as the attitudes that we want to see in our learners. And so, as a teacher, making brief notes on index cards, self-stick notes, or grades, as well as keeping checklists, help you to maintain records of continuous progress and as well as students' achievement. So anytime we observe learners, we are able to find out or identify the learners' progress and achievement. We can also make use of interviews as an assessment strategy. And interviews allow teachers to assess individuals' understanding and their achievement of the prescribed student learning outcomes. And interview also provides the student with opportunities to model and explain the understanding. So you pose the question, and the student is to think about the question and bring out their own explanation to the question that you present to your learners. And interviews may be formal and it can be informal. So in the formal, that is where you have a well-structured kind of questions you are going to give to your learners. So posing physics-related questions during the planned interviews or the formal interviews enable you as a teacher to focus on the individual student skills and their attitudes. And students also reveal their thinking process and the use of the various skills whenever we question them on how they were able to solve a problem, how they were able to arrive at an answer to a question that was being asked them either in the classroom or during a field trip. We can also use group or peer assessment. And group assessment gives students opportunities to assess how well they work within a group. So how they are able to cooperate among themselves whenever they are in groups and they are working. And peer assessment gives them opportunity to reflect on one another's work according to clearly established criteria. So once we give them a task to accomplish in groups, It is likely that they would like to share ideas among themselves. And every idea that a colleague student brings out, they try to assess it to find out whether it indeed that particular idea is good enough and can be a better answer to the question that has been asked. And so during the peer assessment process, students must reflect on their own understanding in order to evaluate the performance of another student. So you can only evaluate the performance of your friend when you yourself you understand the concept, when you understand what you are asking from your friend. And we can also make use of self-assessment. And self-assessment is vital to all learning, and therefore it also forms an integral part of the assessment process. So each student should be encouraged to assess his or her own work. Students, whenever they are doing such things, we should guide them so that they will apply the known criteria and expectations to their work and reflect on their results to also determine how well they are progressing on the various set of instructions that occurred in the classroom. So participation in certain self-assessment criteria and also expectations help students to see themselves as scientists and problem solvers. So when we ask students to assess themselves, they now get to know that, well, they can also solve problems, and they are even able to mimic how scientists do their work. And that is also a way of motivating our learners in the classroom. So it is important that teachers, we model the self-assessment process before expecting students to assess themselves. We must put ourselves as teachers in the shoes of the learners and see how well that if I was the student, can I assess myself? Can I do A? Can I do B? If we find out that this is okay, then we can now give it to the learners to follow that criteria to also do a self-assessment. Another strategy is performance assessment or student demonstration. And for performance tasks, they provide students with opportunities to demonstrate their knowledge, their thinking processes, as well as skill development. And the task requires the application of knowledge and skills related to a group of students' learning outcomes. So anytime we are using performance assessment, then the learners will have to assess their knowledge, they have to assess their skills, they have to assess their thinking process. And all these things are based on a certain criteria. So performance-based tests do not test the information that students possess, but the way their understanding of a subject has been deepened. So anytime we are using performance assessment, it does not just simply provide us information about what the knowledge the students possess, but how well they have understood the various concepts that were presented to them. And so we can provide a scoring rubric that will include a skill for the performance of the task, and it will also help organize and interpret the evidence that is being provided. Again, we can also use checklists or rubrics. And rubrics and checklists, they are tools that identify the criteria upon which student processes their performances or products will be assessed. So that whenever we are developing a checklist, and if it is creativity, or if it is motivation, if it is attitude, we are able to develop the various criteria that is able to bring out the attitude of learners, and all these items are summarized on the checklist or the rubric, and it helps us to assess the attitude of the learners. And they also describe the qualities of work at various levels of proficiency for each criterion. So rubrics and checklists may be developed in collaboration with students or in collaboration with other teachers. So anytime you want to develop a rubric or a checklist, you can involve your students, you can involve colleague teachers, you share ideas on the various items that should be on the checklist or on the rubric. We can also use visual displays. So here, students or group of students will now prepare the various visual displays, and they should be involved in processing information and producing a knowledge framework. So for instance, It can be the model of the atom. Then we make learners get a chart, a visual display of this model of the atom. We can paste it in the classroom and know that before learners will capture this model of the atom, they will try to understand what exactly the various parts mean before they capture it on a chart to be displayed in the classroom. We can also use laboratory reports as an assessment strategy. So laboratory reports allow you as a teacher to gauge the ability of your students to observe, to record, and to interpret experimental results. And so these tools can aid teachers in determining how well students understand the content. So if students are able to interpret an experimental result, then it is also a clear indication that they have really understood the content that they were taught. And we can go by the pencil and paper task as an assessment strategy. And so here we can make use of quizzes and know that quizzes can be used as discrete assessment tools and tests can be larger assessment experiences. And these written tasks may include items such as multiple choice, completion of drawing or label diagram, problem solving, or long answer questions. All these help us to, gain information about student understanding of a concept. And so ensure that both restricted and extended expository responses are also included anytime we are making use of pencil and paper tasks. Again, we can also make use of interpretation of media reports of science. So science short pieces extracted from newspapers could be used to assess whether students understand the scientific content of the piece, whether they can identify and evaluate the possible risk and quality of the evidence presented, whether they can offer well thought out reactions to the claims, and whether they can give their opinion about future action that could be taken by individuals, government, or other bodies. And we can also make use of asking and answering questions based on data as an assessment strategy. And so such questions should assess students' abilities to represent data in a variety of ways. And so students should be able to formulate and interpret the messages that can be extracted from the data, and they should also be able to detect errors and dishonesty in the way data is presented or selected. So the ability of the learners to manipulate and interpret data is a core skill that is of value, not only in science, but also in a wide range of other professions and contexts. Students, in this session, we look at good strategies you can adopt as a teacher when doing classroom assessment. And as we bring the entire module on pedagogical content knowledge in physics to an end, and session 6 of unit 6 to an end, let us have this as a take home. State and explain 6 of the strategies that should be used when assessing physics students in the classroom.